Okay, just a very quick introduction to this one. This is effectively 3 clay videos in one, because I've done one with soft clay, one with medium clay, and one with very hard clay. And these are all recorded at about 20 degrees C, just over. Yeah, and at a later date I then do it at about 25, 26 degrees C, with only the tiniest bit of difference. Just testing out all Gary's claims, proving he's talking a load of old nonsense as usual. Right, I've now altered a lot of my clay to different consistencies, so let's check the weights of them now. They all start up at 280. This is one I left alone. 2.8 kilograms. 2.8 kilograms. The bag weighs a few grams, so let's just bear that in mind. So this is one I left as is. Then the one that was very soft, I added about 40 milliliters of water and pounded it and everything until it was really... So this is gained 40 grams. Yeah, so this is gained 40 grams of water, 40 milliliters, because a litre of water is obviously a kilogram. That's the very soft. 40 millimeters might not sound a lot, but if I make this any softer, it will be ridiculous because it's sticky. There's got to be a limit how soft you can make it. Anyway, it's very, very noticeably softer. It might not seem like a lot, but it is. And ditto, this that's very hard. Here I've lost. So it started off at 2.8 kilograms, then I dried it out to 2.670, so I've lost 130 grams of water on this. Now this was hard work to hammer back into shape, to be honest. It was so hard. I was there for an hour trying to get this into a nice flat solid pancake or whatever. So okay. Now, we also need some information off Gary about temperature, because he claims that temperature alters the consistency of the clay. So I'm going to measure the temperature of the clay, so Gary can then tell us what temperature he thinks it would make it softer or harder. I'll measure the temperature of the very soft clay first, okay? I'll just stick it in this corner, the tip of the sensor. It updates every few seconds or so. Awkward silence. Okay, so that's the temperature of that. Just to prove it's working, I'll put it in my hand so that you can then see. It'll go up in a moment. There you go. So it does actually work. It only updates every, 10 seconds or so. Right, so now let's try the hard clay. Test the temperature of that. Like I say, we need some information off Gary as to what temperature he wants the clay to be to prove his point. He hasn't given us any information about what temperature Emilie du Chatelet might have cheated, in his opinion, to make the experiment work by altering the temperature. So I don't know what it means to make it colder or hotter. A few weeks after I'd already made this video, he did mention that if it got hotter, it went softer. And it does a very, very, very tiny bit. So now we know that heating it up is supposed to make it go softer. But up to this point, I didn't know what he meant. I don't know where he got his information from. He didn't share that with us. Anyway, I found out by actually doing it that making it 5 or 6 degrees hotter, on the hottest day in Britain a few weeks ago, when I did this again, I found that it did make the clay really 1% softer. Some really minor amount that wouldn't really make any difference materially to the experiment. But it didn't. I can put it in the fridge, freezer. I can heat it up, whatever he wants. He just has to give us the information to go on. I can't just guess every temperature imaginable and do every experiment imaginable. If he's going to make these statements, he needs to explain what he's talking about. Anyway, so there. That's the temperature of the hard clay. Let's check the temperature of the medium consistency clay, the one that was as is. I'll put it in the corner because I don't want to damage the clay, the part that I'm going to be using. Okay, so exciting video, eh? Watching a thermometer update in fractions of a degree C every 10 seconds or so. Fascinating. But this is science. This is what people demand. Well, this is what Gary demands, and here it is. I don't know why I'm the only one who can do it or was willing to do it. But luckily I enjoy it up to a point. Sometimes I'm learning for myself. I'm kind of enjoyable on that score. Okay, so that'll do. Very soft clay. Oh, for fuck's sake. Oh, try again. Must do better. I need a clean one. Okay, but I've not left much room. I've not left much room for this much heavier one now. Four times the weight to be dropped from this height. This floppy piece of cardboard is just so I've got a guide where to hold it. I can adjust it so it's in line with the 350mm mark. That's it. Apart from anything else, I don't want to land it on the other balls. Oh, that wasn't too bad, was it? So this was in the softest clay. It really was very soft. Let me try and make sure the camera is getting a good look at it from all angles. Let me get that out now. I expected that to make a mess because it felt so soft, the clay did, when I... Come on, there you go. We only have to look at the holes really to realise that they're almost identical, aren't they? If you look at the mark of the wet clay of the 2.4 kilogram one, and let's look at the one, it's just a bit more difficult to see. Okay, anyway, but we can see there that the oops, sorry, I didn't mean. That's how soft the clay is. I've just damaged the edge by touching it. Let's protect that, move it away, replace that now with, that was a very soft clay obviously, move that away to measure in a moment. Now we go to the medium consistency. It's the same thickness. Yes, the same thickness as the height of the bottom of that, so I don't have to adjust that at all. Right, okay, so that's medium consistency, folks. Okay, same again. So once more, let me make sure the camera appears to be pointing in roughly the right direction. Looks miles too high to me. Okay, so once again now, with the medium consistency, I drop the 574 gram ball from 2 meters. Okay, not a bad hit. And now I repeat the same with this. So, got to get. Oops. It made the mark anyway. It didn't stick in because the clay isn't as soft as the other, so pull that out. Oh, come on. Oh, do you know what I forgot to do? I forgot to do this one from that height in the soft clay, didn't I? So let me do this one from that height in the soft clay. Let's make sure I don't damage the holes we've already got. So I have to cover those up. So I've not got much room ever to get this in. If I can get it there, it'll be a miracle. But I've got to try. It's only going to make a little dent though, isn't it? Because so this is 574 grams dropped from a quarter of the height. So it's going to be a quarter of the energy, isn't it? There you go. Beautiful. Again, I should write on, shouldn't I? So that was 1, 2, 3. That was medium consistency. Hopefully the camera got a good image of it. Okay. 1, 2, 3. 1, 2, 3. It's so easy. Yeah, that looks identical to that. And we know that that's 4 times that because I've tested it before. So that's going to be 4 times that. In other words, clay isn't biased towards speed. If anything, that's marginally more than that, but only a fraction even so. I've brought the soft one back again because I forgot to do that from this height. So I'm going to do that again now. I have to protect the holes I've already got. I don't have much of a window I can drop it in. Got to be quiet. I'm trying to get it to drop there from this height. go. Did the camera pick that up? There you go. That was, let me write down again. That's obvious what that is. That was that one from 1.4 meters. That's number 1. That's number 3. Oh, no, 2, sorry. That's number 2, and that's number 3, obviously. Okay, as long as I can read it. Go and protect it again. Coming up, the very hard clay. The very hard clay now. The very hard clay. Oh. Now this is about 1/4 of an inch thinner. It's not as thick, so I'm going to reduce the height just a tiny little bit. Just a tiny little bit. Take that into account. Yes, yes. So I'm dropping from slightly different height because the clay is lower. You want it on a solid surface anyway, though. But this is very hard. Let me just make it clear. All these experiments are very hard, in fact. He's so funny. Now let's check that the jet of the camera is pointing in the right direction. Use this as a guide. Not sure. Okay, it will have to do. Okay, so once more into the hot, very hard clay. 574 grams dropped from 1.4 meters. Adjusting for the slight difference in. Again, you can tell that it was very hard because it bounced out. There's no way that was going to stick in. But we had a clean drop, but we had a clean hit. Nice clean hit. Okay, on number 1, obviously. So now we do the heavy one. From 1/4 of that height, 350. Yep, that's looking right. Again, that bounced out, so that's number 2. I'm going to try another because I've got the room, so why not? Yeah, you can see it's so hard, the clay is splitting when we hit it. It's like hitting a brick, really. They're all identical, so 3. Well, let's try now the 574 from that height. There you go. Just want to try again. This big one, because it's the most unusual one. Also, I've got the room. Well, I said I had the room. Now I've myself up because I've damaged that one and that one a little bit. Yeah, that was a bad move. I shouldn't have done that, but let me show you what I've just done. Let me show you the bad thing I just did. So that was number 1 made by that ball from 1.4 meters. Number 2 was the 4 times mass drop from 1/4 the height, and that bounced out too. That edge wasn't, because it bounced out that way, that edge wasn't perfect either. Then I did that one and it cracked the clay there. You can see though that they all look identical even before we start measuring. Then I did 574 gram one from the 1/4 height again, which should be 1/4 these in terms of displacement. And then I decided in my infinite wisdom to have another go. I thought I could get it there, and I didn't. I missed and it dropped it there, so I've damaged that hole and that one to a minor degree, only a little bit. It's pushed it in a little bit. Anyway, I could get another one in there, but I'm risking damaging that, so let's leave it. Let's quit while we're ahead. Okay, I think that's it. And the temperature was 20.3. Let's do the normal one first, because we have a reasonable expectation of what we know this is going to be, really. So 1, 2, 3. This is a very soft one, isn't it?
Forgive me, folks, I've made a stupid mistake here. I've only just said let's do the normal one first. Then I went to get the milk and the syringe, and I came back and I thought it was the soft one. I don't know why. I thought it was logical to start with the soft one, then the medium one, then the hard one. And so from here on, every time I put a little label on saying this is the soft one, it's not, it's the medium one. And every time I say this is the medium one, it's not, it's the soft one. So I'm going to have to stick some little titles on the screen to correct this, because now it looks stupid. You can tell which is which by the pattern of where the balls landed and comparing to before when you saw the balls land. I had to double check myself. I thought this doesn't sound right. The results don't make sense. They do now.
Right. We want 10 milliliters. Okay, so number one, the one made with this ball from 1.4 meters. Okay, let's see. I'll be honest, because this is very soft clay, I was expecting this to be much deeper.
Because it isn't the soft clay, you daft. I must have been very tired. I was, well, still am. Always will be, because it's hard work, this is, you know. It's not easy doing this work, you know.
At the moment, it looks no different to the normal one.
Because it is the normal one, Steve.
I'm quite surprised about that.
Well, don't be.
10 milliliters. I'll put some in here now. So this is one made by this big heavy one, 2.3 kilograms. 2.3, not 3. From a quarter of the height. So we know that that has 4 times the energy because it's 4 times the mass. So they're looking identical at the moment, aren't they, really? That might hold a shade more, I think, maybe. See how many more this can take before it overflows. That's the usual way, isn't it? I think that's it. It's just trying to overflow now, isn't it? And that's gone. I'd say that's bob on 7, really. Well, near enough bob on 7. So 13. 13, okay. 13. Let's write that down. I'll write it down here. So.
Oh, great. So I wrote the measurements on the wrong slip. So I've corrected that to, oops, medium. Those are the medium measurements. 13 milliliters, 15 milliliters, and 3.4 milliliters. I've not shown you those measurements yet. And the other one where it says medium, I've had to correct that as well to, oops, soft. What a cock up.
13. Can I write it there? Surely. I've not finished this one yet, have I? Hang on. Up to 10 again. See how many this can take before it starts to overflow. Oh. Yeah, overflowing now. And that's on 6.5, so it's not quite fair because it needs to be levelled up like that, doesn't it? Because you can see there's a lip there. It could take a bit more of that, could it, if it wasn't on a slant. If I level it up just a tiny bit, level it up a little bit. That one's going to spill more now because that one was level, but this one isn't. You see what I mean? I'm trying to show you that edge there. That edge there. It isn't filled up to that edge. Ah, now it's proper overflowing. Call it 5 because it's overflowing a bit. So that'd be 15 really then. 15. So 15 milliliters for number 2. And I'm betting that'll be 3.5. In other words, a quarter of that, or 3 1/4. To 10 again. There you go, filled to 10. And see how much that dropped from 350. Here we go. I need to get closer to see. God, my eyes are bad. Not as bad as Gary's, I don't think. So I'd say that's what's that. 1 6.5, aren't we? 1, 2, 3 and 3.4. Make sure I have filled this up to the brim, yeah. Yeah, I think I have. 3.4, I'd say. Okay, so I need to clear this up now. Clean this up. But that was the soft. So let's now move on to the medium. Now it's going to overflow into that little. See where the where that little thing is dug in, it's going to make milk leak out from there. It's going to patch that up a little bit. So I've just shored that up a bit so it's not going to, and in fairness, the same now when I caught it with my finger. So I'll just shore that up a little bit as well. Just trying to make sure it doesn't leak prematurely. I'm trying to get an accurate measurement of how much each one holds. Here we go again then. Is the camera in the right place? This one. Okay, set to 10 millilitres. Yes. So first of all, number 1. Oh, this is the medium, isn't it?
No, Steve, this is now the soft one.
In other words, the clay as it was.
No, Steve, that was the previous one. This has had 40 millilitres of water thoroughly soaked in and mulched around to make sure it's properly homogenised.
Yeah, that's the point of overflowing, I think, or trying to. So I've done 10, 11, 12, 13, 14 then. Okay, so 14 in this one. So 14 millilitres for number 1. Okay. Yes, 14 millilitres for number 1. And set the syringe to 10. And now we do number 2. The one made with the big heavy one from a quarter of the height. Here we go again. Yes, that holds 10 easily. And set it to 10 again, okay. Yes. I'll tell you what, that looks like it's going to hold 10. Huh? Yeah, 10. Another 10, 20. Fill it to 10 again. I've never had to do this before. Yeah, I think it's trying to overflow this side now, so I'll call that quits now. So we're at, it's on 9, so that's 21 millilitres. That's unexpected.
It's unexpected because I'm still thinking I'm on the medium clay, the normal clay, when in fact this is the very, very soft clay. And what I've not realised yet at this point in time is biased in favour of mass. It's behaving like a non-Newtonian fluid. Now that wasn't in Gary's prediction, was it? As I've explained in another one of these clay videos, I've realised in retrospect that what's happening with this, the heavy one, the one that's 4 times the mass, I've realised that because it's going deeper into the soft clay or the medium clay, it's not going much deeper, but because it's going deeper, I'm having to twist it to get it out, and therefore more clay sticks on this than it does on the other one. So it is going deeper, it is displacing more clay, but the process of me twisting it to get it out, because it doesn't want to come out, it's pretty stuck. I have to, loosen it. It's scraping out a little bit of extra clay, and that's exaggerating just how much deeper it's going. So when this one measures 21 millilitres displaced compared to 14 from that drop from 4 times higher, I think 21. I think that's become exaggerated due to me having to twist it to get it out.
21 millilitres for number, which one is this? Number 2. And last but not least, that one. That proves that Gary's wrong when he claims that clay gives a bias for speed. He claims that it's being biased towards that being dropped from 4 times the height. It isn't. It's showing a bias for mass, not speed. Clay is showing a bias for mass, not speed. Finally, fill this to 10 again. So it's filled to 10. What can this hold? Yeah, that's trying to overflow now. And that's on, yes, that's 3.5 millilitres. 3.5 millilitres, yes. That was number 3. Hole number 3. Now on to the very hard one. I'm going to have to use that one and disregard them for obvious reasons because I've ruined that and that one. So we've got 1, 2 and 4. Be consistent, I'll call this 3. So 1, 2 and 3. Okay, starting with number 1 that was made with that from 1.4 meters. Load it up to 10. You can see the marks are getting rubbed up there, aren't they? You can see 10 here. So number 1. Oh, it's a bit sloped. I might have to just let me turn it this way so we can see it properly. I think I might have to just lift it up a bit to make it fair again. Lift it up here a little bit. Carry on. Okay. So we're on 4.5 at best, so that would be knock up that 5.5 then. 5.5, well, I'll say 5.4. 5.4 millilitres. This is a very hard one. Okay, so the next one, that one, isn't it? Number 2. So let's load up to 10 again. Number 2. Made with the 2.3. Oh, that's it, overflowing, trying to. And we're on 4.5 left, so that's 5.5 again. Yeah, it's 5.5 again. 5.5. And then to comply with the Emilie du Chatelet thing, number 3, the one where that was dropped from quarter of the distance, that should be, what's a quarter of 5.5? Well, if it was 6, it'd be 2, wouldn't it? No, it'd be 1.5, wouldn't it? So it should be about 1.4, 1.3, 1.4, I would imagine. Oh, this camera has run out of either battery or... My main camera has run out of either battery or memory, so now we're reliant on this camera only. So sorry about that. Can't be helped. Let's see what this is. I think that's about it, really, I think. Yeah, that's full, isn't it? Yeah, so you can have to have a good look at that. Sorry, the main camera's just died, so I can't. But you can see we've got left in the tube about 8.6, 8.7. So that means we've got about 1.3, about 1.3, 1.4 in there. So that's exactly in accordance with the Emilie du Chatelet thing. So 1.3, 1.4, that's number 3. So there you go. So that was for the hard one. Okay, those are our results.